For today's mini lesson, we are going to look at significant figures. By the end of this, you will be able to express and manipulate chemical quantities and biological numbers using scientific figures. And you're going to be able to properly communicate and process with respect to the correct use of significant figures. So, significant figures in a measurement consist of all digits known with certainty plus one final digit, which is estimated. So if we look at a ruler and it goes to the tenths place, then we want to estimate with certainty in the hundredths place. So one extra digit. So there are 4 rules for significant figures. The first rule is any number that is not a 0 is always significant. So right, I've got 3 sig figs. So zeros between non-zero numbers are always significant as well. And then zeros at the end of numbers are only significant if a decimal place is present. And zeros at the beginning of the numbers are never significant. So, as you can see here, there is a decimal place. So if I put a 0 back at the end of this, it would be 2 significant figures. But I don't start counting my significant figures until I reach my first non-zero number. So how do we determine significant figures? So we look for non-zero digits, and they are all significant. And then we look for zeros between non-zero digits. Those are also significant. Then we start looking for a decimal place. If there is no decimal places, you have calculated the total number of sig figs. If there is a decimal place, we count all zeros to the right of the last non-zero number. Those are significant. So let's do a couple of practice problems. All right. So I want you to take a second and identify the number of significant figures in these numbers. All right, so to identify, let's go through the first one. So I'm going to count the number of non-zero numbers, right? Cool. Do I have any zeros between non-zero numbers? No. Do I have a decimal place? No. So I have calculated the total number of significant figures. I have 4. All right, let's do this one together as well. So count the total number of non-zero numbers. 1, 2, 3, 4. So non-zero. Then count the zeros between non-zero numbers. 1. Do I have a decimal place? Yes. So any zero after my last non-zero number is significant. I can add them all together or count all my underlines, and I have 6 sig figs. So I'm going to give you another couple of seconds to answer this problem. I want to know how many significant figures are in each one of these numbers. So now that we've looked at what the significant figure rules are, now let's talk about rounding. So rounding in all of science is used to make sure mathematical calculations are only as precise as the least precise measurement. The precision of a calculation must be identified by the precision of the original measurement and must follow the significant figure rules and calculations. So let's talk about rounding, because I see a lot of students struggle with rounding. So numbers 1 through 4, we round down. So it equals then 5 through 9, we round up. So if I look at example 1, I have 5 sig figs and I want 3 sig figs, right? So it's 1, 2, 3, right there. I'm going to truncate the number. So 4, going to truncate the number here, and I'm going to look at the number right of my line. That number is higher than 5, so I'm going to round up. The next number, 8.0065, I want 2 significant figures, so I'm going to draw my line at 2 significant figures, look to the number to the right. It is a 0, so I'm rounding down. Then my final one, I have 0.0562. I want 2 significant figures, so I'm going to draw my line here. This number is less than 5, so I'm going to round down. My final answer will be 0.056. So, when adding and subtracting, the number must always have the same number of decimal places as the measurement with the least number of decimal places. For multiplication and division, the answer must have the same number of sig figs as the measurement that has the least number of sig figs. And then when we get into conversion factors, it does not matter. You always look at the number or the measurement you originally started with. Conversion factors are equal to 1, so they are not used when determining significant figures. So let's look at adding and subtracting first. I'm going to do the first one, and then I'm going to let you do the second one. So 6.21 plus 1.0009. So my answer oh, my 9 disappeared. 1.2.7. This is my raw answer before I do sig figs. Now I'm going to calculate the sig fig, or the decimals. I have 2, I can't count, 2, and I have 1, 2, 3, 4 spots behind the decimal place. My answer only needs 2 behind the decimal. Truncate it here. Do I round up or down? Down. So that would be my answer. All right, I'm going to let you do the next one on your own. All right, let's do some practice with multiplication and division. So 8.68 times 4.3 would be 37.324. Now I'm going to count my sig figs for this one. This has 3 sig figs, and this has 2. So my final answer is going to require 2 sig figs. 1, 2. I look at this number. Do I round up or down? Down. My final answer is 37. Right, I'll let you do the next one on your own. All right, so the final one, we see them combined, and we're going to follow the rule of PEMDAS. When we do this problem. So we're going to multiply first, use the correct number of sig figs, and then we're going to add or subtract, and then follow the decimal place. So here I get 82.15671722. I have 1, 2, 3, 4, 5, 6. Here I have 1, 2, 3, 4. So I'm going to have 4 sig figs. 82.156 is 6 up or down. It's up. And then I'm going to add 12.1. So I get 94.25. And I only need 1 behind the decimal place. So I round up again. So it would be 90. 4.3 be my answer. All right, so Our final thing is when taking measurements in the lab, only report significant figures, record all digits that you are certain about, plus one slightly uncertain digit if you are able to. Always take measurements to 1 decimal place past the smallest graduation line. Estimate 1 additional digit after the digits you know for certain. Graduated cylinders, rulers, and thermometers. Beakers, flasks, and bottles are not used for measuring. Measure only with graduated cylinders. When using an electrical balance, record the entire number on the screen. Follow the same procedure for any digital measuring device. They give you that one extra uncertain number. You do not have to guess. There's no way to guess. All right, I'll